Dual nature of matter and radiation. Some typical questions on this particular chapter. First important question: how many photons are emitted per second by a 5 megawatt laser operating at 632.8 nanometer? That is the question. How many photons are emitted per second? So we know the energy is equal to h nu or h c by lambda. That's a basic equation or formula. So we are going to put this value and like 6.63 into 10 to the power minus 34 joule second for the Planck's constant, and c is your 3 into 10 to the power 8 meter per second by lambda. Lambda is how much? 632.8 nanometer means 10 to the power minus 9 meter. So if you are going to calculate, the calculation skill is also required. If you are going to calculate, you will get 3.14 into 10 to the power minus 19 joule. One very important point is there. Here h and c, if you are going to multiply h and c, you can apply directly 1240 nanometer. If you are going to multiply h and c, that's the constant h and c. If you are going to multiply directly 1240 nanometer, if you are going to remember it, you can apply in the exam hall also directly. So if you are not remember, then you have to proceed in this way, and so you got the energy is this. So here it is given the energy of the laser emitted. Energy of laser emitted per second. Emitted per second will be 5 into 10 to the power minus 3 joule. How it comes? Energy per second. That's the power is given milliwatt, 5 milliwatt laser. So here 10 to the power minus 3 joule. So that we can easily find out with the help of this. We can write energy, and power is what? Energy by time. That's a. So we can write energy emitted per second is this much. That should be. So therefore the number of photons emitted पर सेकंड, एक सेकंड में कितना फोटोन निकला, उसके लिए एनर्जी कितना? 5 into 10 to the minus 3 joule by what? The total your 3 point whatever the energy we got in this particular case, 3.14 into 10 to the power minus 19. So that comes out to be, if you are going to calculate, 1.6 into 10 to the power 16, कितना photons निकला है, number of photons emitted per second. Another question: a monochromatic source of light operating at 200 watt emits 4 into 10 to the power 20 photons per second. Find the wavelength of the light used. This is also more or less same. Lambda is equal to hc by E. So just you apply the different values. hc I told you how much, directly you can apply 1240 nanometer, and E is also given, so you can easily find out with the help of that equation. This calculation part is there and you can easily find out. Another typical question: a parallel beam of monochromatic light of wavelength 500 nanometer is incident normally on a perfectly absorbing surface. The power through any cross section of the beam is 10 watt. Find the number of photons absorbed per second by the surface. Number B, the force exerted by light beam of the surface. दो चीज निकालना है. The number of photons absorbed per second by the surface and the force exerted. So how we are going to solve it? First part is your E is equal to hc by lambda. So by putting the value of this h and c, so we will get it right. Now hc, as I told you, 1240 nanometer. Or one more point is there. If you are going to express in electron volt nanometer, then 1242 electron volt nanometer by lambda. Lambda is how much? 500 nanometer. So that comes out to be 2.48 electron volt. If you are going to divide, you will get it this much. See? So now the point is, itna energy. So in 1 second, here it is given that 10 watt. Here 10 watt. So we can write it in 1 second. In 1 second, 10 joule of energy passes through any cross-section area. Thus, the number of photons हमको पूछा, number of photons crossing a cross section is equal to 10 joule by 2.84 इलेक्ट्रॉन वोल्ट. तो कितना इलेक्ट्रॉन्स हो जाएगा यहाँ पर? 2.52 into 10 to the power 19. If you are going to calculate, you will get इतना photons cross कर रहा है इस cross section area, right? That number of that n हम निकाल लिया. 10 joule by 2.48 इलेक्ट्रॉन वोल्ट, इतना इलेक्ट्रॉन क्रॉस कर रहा है. So this is also the number of photons falling on the surface per second and being observed. The same thing is that this is also the number of photons falling on the surface and that is being absorbed. यही तो हमको निकालना था. Number of photons being absorbed. This is this much. Now second part is interesting. The force exerted by light beam on the surface. Second part B, force exerted हमको निकालना है. तो ध्यान में क्या होना चाहिए कि अगर हमको लीनियर मोमेंटम मालूम है, लीनियर मोमेंटम अगर निकाल लिया तो हम लोगों को फोर्स निकालने के लिए इजी हो जाएगा, बिकॉज वी नो फोर्स इज इक्वल टू dp by dt फ्रॉम सेकेंड लॉ ऑफ न्यूटन्स मोशन. तो उसको हम डिफ्रेंशिएट कर देंगे टाइम के रेस्पेक्ट में एंड विल गेट द फोर्स. सो सबसे पहले P इज इक्वल टू फॉर्मूला h बाई लैम्डा, h न्यू बाई c, h न्यू बाई c, या लैम्डा की जगह लिख दिए न्यू बाई c. सो देयरफॉर टोटल momentum of all photons, जितना ही photons है सबका total momentum falling per second on the surface is equal to n h nu by c. n कहाँ से आएगा? नंबर ऑफ फोटोन्स, टोटल नंबर हम लोग पूछ रहे हैं, यहाँ पर पूछा गया. तो ये निकालने के लिए that comes out to be 10 joule by c. If you are going to calculate, you will get the 3.33 into 10 to the power minus 8 न्यूटन सेकेंड। इतना आ गया क्या, टोटल मोमेंटम। अब टोटल मोमेंटम आ गया तो हमको फोर्स निकालना है। फोर्स इज इक्वल टू dp/dt। सो dp चेंज इन मोमेंटम हो गया, दैट इज 3.33 इंटू 10⁻⁸ न्यूटन सेकेंड बाय change in momentum by net time 1 second, that comes out to be 3.33 into 10⁻⁸ Newton. That should be your answer. Another interesting question, ultraviolet light of wavelength 280 nanometer is used in a photoelectric experiment with lithium cathode having the phi 2.5 electron. Phi means a work function. Find out the maximum kinetic energy of the photoelectrons and stopping potential. So here we are going to use the Einstein's photoelectric equation. That is your maximum kinetic energy they are going to ask. So kinetic energy maximum according to the Einstein equation, that is your H new incident means C by lambda minus phi. Now this K max is equal to hc by lambda minus, so K max is equal to hc by lambda minus phi naught. K max is equal to, in place of hc we are going to write directly 1242 electron volt nanometer by lambda minus 2.5 electron volt it is given. So the value of the lambda also we have to put to 1242 electron volt nanometer, and here it is lambda is also given, that is your 280 nanometer minus 2.5 electron volt. So directly we can divide and then subtract. So we will get the 4.4 electron volt minus 2.5 electron volt. That is the easiest method. Don't put the value of H and C and then you multiply. For the numerical, you have to remember that if you are going to multiply H and C, 1242 electron volt nanometer. So if you are going to multiply it, subtract it, how much it will be? That will be 1.9 electron volt. That will be the maximum kinetic energy. Second bit is your, you have to find the stopping potential. We know the maximum kinetic energy is equal to stopping potential, that is the charge on electron and the stopping potential. So we can write it V naught stopping potential is equal to K max by E. So here 1.9 electron volt by E means electronic charge by E. If I am going to now just to see one more interesting point is there. If you are having the value of E and here in the K max is in terms of electron volt, directly you can cut it. So no question of that. If you are putting the value of E and then you cut, you just divide it. So unnecessary, not required. That is the 1.9 volt. That should be your answer. This is the best way to find it. Right? 1.9 electron volt.